And recently I've read that the Albertan government has become concerned that there just isn't enough water for all of this. They're increasing the charges for water, and apart from the charge, there just isn't enough of the stuff there to expand the thing infinitely. So although it can be expanded further, although it can be quite profitable, you can't see an explosion of oil from these tar sands. Important, by all means, to ameliorate the subsequent decline, but very little impact on peak itself. And that's really Canada's situation. There's a lot more gas up in Canada, of course, but it's far away, it's Arctic, it's expensive to produce, and give a lease of life of a number of years, a decade or so, but not too much. And of course, Canada is a neighbor of the United States, and under NAFTA, it's part of this free trade organization. And so it's effectively being drained by the United States of its gas, so far apparently with goodwill on everybody's side, but one would imagine the freezing Canadian winter in due course might compel people up there to think, well, wouldn't it be better to heat ourselves rather than export our precious resources for somebody else? This in turn carries, of course, enormous political consequences on the relations between America and Canada, and then in the meantime, of course, the American companies, oil and gas companies, have been buying up Canadian ones as fast as they know how, simply because they have nothing much left at home. And so I think this is a looming kind of political problem for Canada to, if it starts restricting supplies to the United States, well, it faces at an extreme case, they'll need to get these Mountie fellows out again to defend the frontier. You know, that's overstating it, but anyway, there was some kind of tension would likely arise.
Are crustal hydrocarbons and gas hydrates going to save us?
We've talked about conventional oil and non-conventional oil. Now there's still further, more extreme notions of still other kinds of oil that might be there, and we might touch on the theory of the gold theory by Thomas Gold, the physicist, who developed the theory that oil came from not algae such as I've described, but from deep in the Earth's crust, left over some primordial event in the formation of the Earth when hydrocarbons were formed. Now this might or might not be an attractive theory in astrophysical terms, who knows, but one can say that it is not accepted by the industry in any sense, and that since the 80s, the geochemical revolution of the 80s, which gave us for the first time really, before we had kind of a gut feel for what a source rock was. If it looked black and it stank of oil, you'd say that was a source rock. But then in the 80s came isotopic work in geochemistry, which was able to identify the isotopic signature of algae and chlorophyll and so forth in the oils, and it could relate the oil in a well from the source rock from which it, not the reservoir, but the source rock where it was formed. So this advance in chemistry has really explained most oil accumulations. Now there are a few people still going around promoting this idea of the crustal origin of oil, and they draw attention to various reservoirs where oil does occur in granites. For example, the famous granite wash of Oklahoma, which is the surface of a granite that is eroded, weathered, fractured, and oil from quite conventional sources has collected in the top of this ancient crystalline rock. And it's not the only example, there are several around the world. And there's one man, Mr. Kenny, who is a member, surprisingly, of the Soviet Academy of Sciences, and he has, over the last few years, in fact, he intervened with the IEA to say that, well, Russian research confirmed this idea of deep-seated origin of oil, and that there were fields in the Ukraine that so demonstrated. Well, the German Geological Survey took this proposal serious enough to go and investigate, and found yet again that there were, although indeed it did occur in crystalline rocks, there were perfectly normal explanations of conventional source rocks on the flanks of the structure, and it had just migrated in to fill it up. Then the Swedes a few years ago were somehow persuaded to deal with their own energy security by drilling two 7,000-meter holes into a meteor crater place in a granite body in the hope of finding this deep oil, and they failed. So really this is a red herring of no substance, but there are still certain people who promote it and maybe even believe in it, and it's, you know, there's perpetual energy machines, and, you know, there's no limit to the extreme solutions that people may dream about. Then the other thing that's almost as bad as that is hydrates. And this is another complicated story, that hydrates have long been known to the oil industry. They're kind of an ice-like molecule containing methane. And this forms in cold conditions, and it's been a source of a nuisance for the industry, clogging pipelines and so forth. It occurs in cold conditions, and there was this field in Siberia, Mosayayaka field, that somehow word flowed out, and when it was in the Soviets, that this was producing from methane hydrates. So there was another flurry of interest in this new source of oil, and then some Russian physicists determined the physical conditions under which this stuff formed, and found that it would occur in permafrost conditions in the Arctic and also in the frozen depths of the ocean. And so then an interest turned to finding this stuff in the ocean depths. And quite apart from that, there's been oceanic research going on, drilling holes into the seabed for academic research and so forth. And they identified a seismic reflector. It was supposed to relate to the deposits of hydrate that were there. And these academic wells that were being drilled were drilled without blowout preventers, and the last thing they wanted to find was a hydrocarbon accumulation. So they deliberately located these things away from this seismic reflector that was supposed to indicate these hydrates. Well, eventually, about 2 years ago, on the Blake Plateau off the United States, they finally went deliberately to investigate this seismic reflector, and when they drilled through it, they found, in fact, it didn't reflect any hydrates, and it was just an artifact of the seismic. They have a thing called a multiple, where you get sort of multiple echoes off something else. So it was dismissed. Now, the record to date of finding hydrates has been extremely irregular. You may find a meter or two somewhere, drill another well 100 meters away, and there's nothing. So this occurs in granules and in laminae, and locally you may get a little pod of the stuff. And so it's so disseminated, and since it's a solid, methane can't accumulate in one spot sufficiently to be an economic deposit. Now, there's still another confusion, since nothing is black and white in any of this business. You sometimes get seepages of ordinary gas that come to the seabed, and you may get a big pod of hydrate formed on the seepage of the gas from depth. And here you get a big chunk of the stuff. And well, by all means, it's a little deposit that under some extraordinary, expensive and difficult technology could perhaps be produced. But it's small, and it's limited, and it's local, and this is no panacea to solve the future. But it's a golden story for research. You can go on studying the damn thing forever. Every result gives equivocal answers, and so you can do more. And the Japanese, who are so concerned about their own energy supply, have sponsored a lot of work in this direction, and they've even got a special boat built to investigate all of this. But it continues to offer equivocal or negative results. And it's well said that this is the fuel of the future, and likely to remain so.
Will Russia be able to fill the gap?
A great deal of interest attaches in these days to Russia, and could Russia perhaps now make good the shortfalls elsewhere, and what is the role of Russia in the future? Well, Russia has had a very ancient oil industry going back to the Caspian days of the 19th century, but with the communists and everything in the interwar years, it didn't do too much. And the great boom of the Russian oil business came after the Second World War, and they were very efficient explorers, because whereas in the West we had to pretend that every piece of information we liked to drill wells to learn what the geology was so that we could plan things properly, but nobody would pay for such activity unless it was perceived to be a potential oil prospect.